Hello everybody, it's time again for another screencast lecture, and today we're going to continue our discussion of earth science, and the topic today is going to be types of faults and stress, primarily focused on earthquakes. Are you ready to go?
I'm ready, are you?
I'm always ready. Here we go. Okay guys, first let's take a real quick review. This will help us to get ready for today's discussion. First question, plates sliding past each other form a what type of boundary? Transform boundary, correct. And here's an example of a transform boundary. The most famous example would be this fault right here, and that fault is called the San Andreas Fault. What is a very common occurrence at a transform boundary?
Common boundary?
What would you expect? What kind of occurrence would you expect to find at a transform boundary? Earthquake! Yeah, that's right. Good answer. Earthquake is correct. We should expect earthquakes at a transform boundary. Okay, this is a neat picture. Take a look at it. You can see the very different shifting of the lines. Here's a highway. This line used to be over here, and they shifted several feet over. Now, an important term that we all need to know is the word fault. A fault is a break in a tectonic plate. One way I like to remember that is to think about that if you break a plate, it's your fault. Isn't that clever? Now, we know about earthquakes occurring along plate boundaries, but what about areas that are not near plate boundaries? Is it possible for earthquakes to occur there? Well, yes, actually it is possible to have that happen, and these areas are deeply buried faults, and sometimes they're referred to as intraplate fault zones. Intraplate fault zones, and here you see some examples of those that are here in our very own United States. These are going to be weak spots that are in the middle of a plate. A great example, and one that I'm going to expect you to know, an example of an intraplate fault is the New Madrid fault. Is a very important fault. One of the large cities in Tennessee, Memphis, Tennessee, is located very close to the New Madrid fault and is in particular risk of great damage. The New Madrid fault is considered a very high risk fault. In fact, in 1811, there was a very large series of earthquakes that went from December 1811 all the way through the rest of winter 18 into 1812. Those series of earthquakes rank in the top 20 for the largest earthquakes in the history of the world. Eyewitness reports even report like the Mississippi River reversing course, shifting over quite a bit of distance. Very big deal. Now, why do you think that not too many people were injured? Why do you think that was? Well, at the time, that area was not very well populated, mostly empty fields, forests, trees, things like that. Nowadays, a lot of people live in this area, and if an earthquake of this size happens again, it could be a very big problem. Now, what about Ohio? Does Ohio face any earthquake risk? Unfortunately, yes, but fortunately, the risk is very low. And you can see the risk in this gray area. That's considered a 0 to 4. We're here in this light blue area, which is a 4 to 8. The west coast, where the San Andreas Fault is, that's a 64 and above. So very high risk here. Basically almost no risk here and very low risk where we live. There have been 5 earthquakes in Ohio since the 1930s that were magnitude 4.5 or higher. The most recent was in 1986, so before your time, but it has happened and it could happen again, but hopefully it won't. How do these earthquakes occur? Now, we can have a good understanding about the plate boundaries, where plate boundaries will be sliding past one another and get stuck and then slip. We can understand that pretty well. But what about these other types of earthquake areas where you don't have these big massive plates sliding past one another? You do have some different kinds of stresses that can be on the rocks. Like, for example, electric potential energy is stored in these rocks, and that energy is under pressure. When it reaches what's known as an elastic limit, the plate will break and release the energy of an earthquake. So we can see here, if we take this stick and we bend it somewhat, and then I just release it, it has stored potential energy. It has the ability to spring and bounce like that. Now, if I were to increase that stored potential energy and I get past what's known as the elastic limit, I can stretch it and bend it and bend it and bend it. Oh, and there it goes. And one of the interesting things about that is you can't really anticipate when it's going to really reach that elastic limit. So you don't really know exactly when it's going to snap, and you can bend it up, and there it goes again. So that could be an example of a way that one of these earthquakes can occur. And that brings us to the concept of stress. Now, most of us understand stress like in our lives. Oh, I'm so stressed. But when we're talking about stress in terms of physics and geology, we are talking about the physical pressure. It's a pull, or it could be other forces exerted on rocks, and that is what's known as stress. First form of stress that I am going to expect you to be familiar with is compression. Compression is a stress where rocks are going to be squeezed together. So if you think of pressing together, the rocks are going to be squeezed together. That's compression. Folding is when rocks are bent under that pressure. So you can see the compressive force pushing in from both sides, and the rocks can actually be bent, and that would be known as folding. You can kind of see that in action. If we push both directions, you can start to see this rock layer starting to bend like this. It could bend like this. It could bend like this. It could bend like that. So many different ways you can get this rock layer to bend. So you can get all different kinds of shapes when we're talking about folding. And again, what is the type of stress that causes that? It is compression.
There's gonna be an earthquake in this town. There will be houses falling down. The fire hydrants will blow up. The streets will crack.
The rest that I'm going to expect you to know is tension. Now, tension is the opposite of compression. Tension is when a rock or a plate is being pulled in opposite directions. Think of a piece of paper and we're pulling it in opposite directions. You can feel that stress in there, and it could actually pull and be torn. That would be tension. A rubber band would be an excellent example of tension when you stretch a rubber band or when you stretch a spring. Here we see tension forces on this rock cause these interesting crystals to form. You can see the crystals have been stretched out. Here's another example. You can see the interesting forms of these crystals that have been stretched.
It's always fun living in LA. Always a good show on somewhere. What more can I say? There's gonna be an earthquake, I can't miss it, no way. I'm gonna run, we're having so much fun. 'Cause there's a building chasing me. Smack, I just fell in a crack.
Shear is a stress where rocks slide past one another. So you have stress in this manner. So shear, and a way that I like to think of that, if you think of like hair shears, like scissors, where the scissors they slice past each other. That's shear.
There's gonna be an earthquake in this town. The dogs are chasing their tails around. There is a buzzing in the air. Maybe I'll die, but I don't care. My surfboard's ready for the tidal wave. I'm gonna ride down Sunset like a beach boy today. I only hope I don't wipe out in West LA.
Quick review. Faulting is when tectonic plates are broken or cracked. Again, remember if the plate is broken, it's your fault. Here you can see fault here. You can see these breaks in the rock layers here and here. Folding is when rock layers are bent, and the type of stress that causes folding is going to be compression. Here's a couple photos showing folding in rocks. Take a look at this picture. I think this one's pretty interesting. You should be able to see folding and faulting. Like, for example, here is a break, here's a fault, and then you should see numerous examples of folding in these rock layers. Well, that's all we have for you today. Hope you learned something, and we'll catch you next time. See ya!